To our session. Welcome to VFX Summit 2021. It's been a long day. We almost have 5 to 6 sessions that happen already, and I'm sure the audience are looking forward to this session as well. So we have Frederic Servant who joined us from London. He's a senior software development manager at Autodesk, and where he looks after the Arnold core and plugins developers scattered around the globe. He was previously the main developer of Arnold integration in Houdini. Prior to working on Arnold, Frederic worked as an R&D engineer at the Mill in London and La Maison in Paris. Excuse me, Frederic, if I did not pronounce any of those words correctly. My bad.
Fine.
I'm just the host here. I take care of the event, so I'm I'm looking VFX from an outside perspective. So excuse me. So Frederic is going to do a session for us, a workshop for us on amplified rendering performance in Arnold, and you can post any questions in the Q&A sessions while you listen to him. And over to you, Frederic. Thank you.
Okay, thank you. So yeah, let me start by sharing my screen. There you go. So yes, so I am based in London. I manage, as you said, the whole of the Arnold team. I look after the development of the core technology, but also the integration in all the plugins, but also support and documentation. Okay, so let's get started. So here's the agenda for this presentation. So after a brief introduction, I'm going to generally talk about the latest release of Arnold, which is Arnold 7, that was released a few weeks ago. And I'm going to highlight some of the features of Arnold 7 and some of the features that were released previously. And I'm going to specifically highlight denoising, some GPU update, especially on performance and scalability. I'm going to also talk about USD, and then we'll have a conclusion, and I hope we'll have some time for some questions at the end. So if you have any questions, please write them down in the Q&A in the Q&A window, and then at the end of the session, I'll take some time to answer those questions. Right. So, brief introduction on Arnold. So, if you don't know what Arnold is a renderer, is an offline production renderer, that really pioneered the use of path tracing and ray tracing and path tracing in production. Some of the specifics of Arnold is that it scales very well for large scenes, and this is coming from its VFX background, feature animation background, where really it was designed to handle large scenes. Also, it aims at addressing complex rendering challenges, like really with production features and specific looks. It's very customizable. It comes also with a very comprehensive API, both in C++ and Python. We've introduced, like for, I think it's 2 years. Is it 2 years or 3 years? I can't keep track. We've introduced GPU rendering, and it's compatible GPU and CPU rendering. It's not a separate renderer. It's the same renderer. You can use the same scenes, and it will render either on CPU or GPU. And you can even change from CPU to GPU on the fly, interactively, live. It now ships with Maya and Max, where it's the default renderer, but also it's integrated with third-party DCCs, such as Houdini, Katana, and Cinema 4D. So those are the ones we support, but there's also unsupported integrations, for example, in sorry, I forgot the name. Well, in other DCCs, right? Recently, we were recognized with an engineering Emmy award for our work, and in TV and series where Arnold is used extensively, and so we received this award about a month ago, and we're very happy about this. So let's move on to the first part, which is about denoising. So before we talk about denoising, I would like to give you a reminder about this feature that we introduced in Arnold 6.1, I think, which is the images framework. So what are images? So images is a post-processing framework that we introduced in Arnold. So that basically takes care of 2D operations after you render. And you can, those 2D operations like operate on pixels, and they can take as input AOVs. Like they can take the beauty or AOVs. So it's fully interactive. It's also integrated in the Arnold render view in Maya and Max. So you can see the results directly, but it's available in all the plugins we support. And because it's part of the Arnold scene, it works in batch too. So you can have 2D operations that you save in the scene, it's sent to the farm, and it's going to be applied to when you render on the farm as well. Right. So typically, those images are used to do color correction type operations, such as color correct or lens effects like vignetting, or to add effects, 2D effects such as glow. Actually, it's presented as bloom. That's the name in Arnold. So this is another example. So this is a purely 2D operation that you can do, that you could do in a compositing package such as Nuke, or you could do in Photoshop, but it's just integrated in Renderer. Okay, another cool example of imager is the light mixer. So you can render your scene in separate AOVs for different light groups, and then you can assemble them together in the light mixer and interactively tweak the intensity of all the lights, and you can tint them. So that gives you a very easy interactive way to tweak your lighting after rendering, so very quickly. So images, being 2D operations, are a perfect fit for denoising, and that's what we've been doing. We've migrated our denoisers. We have several. I'll talk about the different denoisers later, but they are now just like color correction. They're a 2D operation, and you can add them to this stack of 2D operations. All right, so in Arnold 7, we introduced this new denoising engine, which is the Intel Open Image Denoiser, that is available as a new imager. And here's an example of the quality you can get with this denoiser, right, on an interior scene. Here's another example with a character scene. You see, we're pretty happy with the quality. It's a good denoiser. And what's important is that it gives you a choice, an extra choice for denoisers. So in Arnold, we already had two denoisers. We had the Nvidia's optics denoiser and the Arnold denoiser, which is called noise. So here's a table that shows you the differences between those denoisers. So the first two ones, so optics and Intel, they are AI accelerated, and thus they are pretty fast. The difference between the two is that the optics denoiser runs on GPU, whereas the Intel denoiser runs on CPU. Okay, The Arnold Denoiser is not AI accelerated. It's just slower, but it has some production features such as the ability to denoise the AOVs that compose the beauty, and so that they actually add up to the beauty. It also has temporal stability, so you can feed the denoiser some images before and after the image you are denoising, so that it smooths out any the denoising, and there's no extra noise that is added, so extra low frequency noise or blotching in an animation. So that's a way to make sure that the animation is stable, the denoising is stable in animation. So that's a feature of the Arnold Denoiser. Okay, but I would say now I'd be tempted to say, if you don't know which one to choose, you should really start with the Intel Denoiser. Why? Because it runs everywhere. Like, it runs on CPU, so it's going to run everywhere, and it's really fast, and the quality is really good. With a GPU accelerated denoiser, such as the optics, is going to be faster, marginally faster, but you have to have a GPU. So yeah, you should try this first. Sorry, this is not meant for this, but I'm going to talk. Yeah, let's see it in action. So not only does it denoise, well, it's an interesting denoiser in itself, but I wanted to show you optimizations that we've done to denoising in general, and that benefits all of the denoising solutions in Arnold. So what you're seeing now is an interactive walkthrough in an interior scene, and as you can see, it's difficult to see where you're going. If you it's very, very, very noisy, and it's difficult to understand anything. Now, with the improvements that we've done, both with new denoisers, but also denoising low resolution passes, we get something that is very interactive, and you can see where you are in this kitchen. Now you can understand that this is actually a kitchen, and as you release the mouse button, you can see that it very quickly converges to something pretty high quality. Okay, so what you see on the left is what we had in Arnold 6.2, and this is Arnold 7. So much improved interactivity with denoising, and generally. Okay, so here's a bit of explanation. So, like, we wanted to make it fast enough for IPR, and the Intel Denoiser is definitely fast enough for interactive rendering. Also, you can see that the negative AA passes are being denoised as well, and all this is happening on CPU. As I said before, it's not temporally stable, but I would say that if your images are converged enough, if there's not too much noise, you should try an animation. It could work, and actually I know that it works if it's converged enough. Now let's explain a little bit also what we've improved in the denoising itself. So this is with the optics denoiser. So in Arnold 6, this is with this kind of raw render, and if you have a scene that has some refractive surfaces, so I know it might be difficult to see, but there's like a thick glass pane in the middle of this kitchen. For the sake of this example, and you can see that the denoiser has a hard time figuring out what is behind this glass pane, so it's very blurry in the center. The rest is okay, but behind this glass pane, it doesn't really work. And this is because what is like the AOV, the albedo AOV that is helping with the denoising doesn't take into account anything that is behind a refractive surface. So all the specular paths are not part of this albedo. So in Arnold 7, now we have a new denoising albedo AOV that goes through refraction and also takes specular into account. I'll show this later. So now with this kind of auxiliary AOV to help the denoising, you can see that behind this glass pane, like everything is really well denoised. So that's a big improvement. Again, side by side, optics. With Arnold 6, it's the same denoiser optics. That's the same result you will have with the Intel denoiser. What we had with Arnold 6 was very smudgy behind refractive surfaces. Now you can see that it's very clear. So that's a big improvement. For specular paths, we had the same problem. And this is the case for this character image. As you know, hair is mostly specular, so it didn't show up in the albedo in Arnold 6. Now, in Arnold 7, it does show up, and you see the color. It's a bit noisy, but that's fine. And it's going to help with the denoising. And this is a comparison. With Arnold 6, with an optics denoiser, you can see the hair is not well defined. It's very smudgy. We've lost all the detail. And that's the same render time with Arnold 7, where the denoiser is able to pick up the detail. Right, that's it for denoising. So let's move on to GPU scalability and performance. Before, as a nice segue with the previous part, I'll show you this little animation. So this is not on GPU, this is on CPU. I think with the compression, it's going to, like the animation is going to show up choppy. But like, believe me, it's pretty smooth and interactive. I don't know, it's like 15 frames a second. And this is all running on CPU. And this is to show you that for Arnold 7, and like a big focus of ours has been to improve performance and especially interactivity. And so the denoising is part of this, because we know that it's an opportunity to have like a faster, more interactivity, less noise, so give a better preview of what the render is going to look like quickly, so that you can make artistic decisions faster. And so, but we've improved the interactivity throughout, like on CPU, on GPU, on many fronts. And if you add everything together, you can get this kind of interactivity, even on CPU only. Here's another example of our focus on performance in the last version. So this is the Toon Shader. It's very widely used shader for animation, obviously. So if you didn't know what the Toon Shader is capable of, here are some examples of the various looks you can achieve with the Arnold Toon Shader. It's very, very customizable, configurable. Another example. And what we've done is that, like, we've improved, and that's a collaboration with Intel as well. We've improved its performance drastically. There was a common bottleneck coming from the feedback from some of our customers, some studio customers, and this is the result. So the Toon Shader, like that's the new. On the left is the new Toon Shader, and that's the old one. And you can see, I can't remember exactly what the speed up was, right? I think it's 4 times. Okay, and this is how the Toon Shader looks in interactivity. Okay, another type of improvement that we do is not just on code, but also on the maths. So the maths for the sampling, and especially the adaptive sampling, have been improved drastically over the last versions. It's not in Arnold 7, it predates Arnold 7, but this is included now. And you can see the difference. This is the same render time, but with better maths, improved maths, we're able to get rid of the noise more quickly. Okay, moving on.
We continuously release new versions of Arnold, and we added new things.
Sorry about that. This is showing like the journey we've been on with Arnold Gpu. So Arnold Gpu, we released the first version in 5.3, and throughout the versions, now we are on 7, so you see all the major versions that are there. They have we've added features to have the same features that we have on CPU on GPU, and you see there's lots of them. There's some big ones such as OSL, OpenVDB, light linking. I don't know, like there's lots of them. So it's been a long journey. We still have some of the features are not supported on GPU, but there's just a few now. Okay, so I think, and we've been prioritizing the features that we port on GPU based on the feedback we get from studios and customer. Okay, so yeah, this really getting close. And now that we have all of the features, or most of the features that we have on CPU on GPU, it's now time to really focus on performance and especially scalability. As you know, you have far less memory on GPU than on CPU, and it costs a lot more. So, and now we're able to really focus our efforts on improving the scalability. And that has started a while ago with the most, the thing that consumes the most memory in the render, which is textures. So this is a collaboration with Nvidia, where we have now streamable textures on GPU. And as you can see, we started very high. So for this scene with it's just a production scene with a robot, it contains lots of textures. We started from 16 gigabytes, and now with the latest Arnold release, like the same image consumes just 6 gigabytes. Okay, and because it's a collaboration with Nvidia, this streaming of textures is hardware accelerated as well. So something that we're continuing with now that memory is tackled. Let's look at the geometry. And so something that consumes a lot of memory, far less than texture, but still a lot. And this is a very recent improvement, as you can see. So Arnold 6.2, 6.2.1, 7, and you can see how it's decreasing a lot. So we have the time to focus on this, and we can apply the same compression techniques that we have on CPU on the GPU code path. All of those were released in the last year. So you can see 6.2 was released in the beginning of the year, and yeah, we've reduced by 2/3 the memory consumption in Arnold 7. For reference, here's the memory consumption on CPU for this scene. So it's still lower than what we have on GPU, but we are actively working to close the gap. We know how to do it. It's just Just need to work a little bit more, but we'll get there. Another big consumer of memory on GPU is volumes. So as you know, we support OpenVDB on GPU as well. But with
Arnold Gpu uses.
So before we were loading all the volumes as a dense volume into GPU memory. It's extremely costly to do this. And now, with a collaboration with Nvidia with the NanoVDB project, which is an extension to OpenVDB that is now shipped with OpenVDB, but we worked early on with them on early implementations of this. We're able to load not the whole volume, but just a sparse volume. So it's very lightweight compared to what we had before. And this is the result. So this is really impressive. So as a dense grid, we're consuming like 3 gigs, over 3 gigs of VRAM for this cloud, so for the Disney cloud. Okay, with NanoVDB, with a sparse representation, and that's already something we shipped in 6.2.1, we're able to consume just over half a gig. And now with Arnold 7, we're applying compression on top of this. And so we're down to 0.3 gigs of VRAM for this volume, which is on par with what we have on CPU. So we're really happy about this result and the great collaboration with Nvidia. And lastly, I would like to talk about
game change.
I'd like to talk about the Ampere architecture. So the Ampere architecture for Nvidia is the latest generation of GPUs. So that you know, and they have done many improvements in there. It's the second generation of RTX hardware, and because of our collaboration with them, I can say that it was designed with Arnold in mind. Not just Arnold, of course. They have lots of customers or people using their GPUs, but Arnold was definitely in their testing and part of the design. And I show you a result. It shows this. So this is a great example of this collaboration, where we were able to have with a scene with motion blur, when there's lots of motion blur, and most production scenes have motion blur. Now in this new generation of GPU, in the Ampere GPUs, it's hardware accelerated, and we designed the motion blur specs with them, so it's fully compatible with what we have in Arnold. And you can see that the render time is less than half what it was on an RTX, and pretty high-end RTX GPU before. All right, and when you all add all of this together, so the interactivity improvement, GPU, this is the kind of interactivity you can get. There's no denoising here. Okay, and we're really happy also to see the reaction of people now using GPU without really thinking about it, and tweeting those kind of scenes done on GPU casually. We're really happy also to get some feedback like this, like very shortly after the release. This person, Ishban, released this great interior image. So interior renders are notoriously complicated for Arnold, but you can see that with the combination of GPU denoising and even some tone mapping, thanks to the new images, is able to render this final image in 2 minutes. So we're done with GPU. I'd like to move on to a very hot topic for us, which is USD. So USD is a super hot topic for us. A lot of the studios are now considering or moving to USD. I would say like really lots of studios are doing it actually now. So, and we've been collaborating with many studios, big and small, who are doing the switch and working with them, getting their feedback to try and prioritize the things they needed to make rendering with Arnold with a USD pipeline possible and production ready, so that they can really do a movie, do a production with USD. A lot of people are thinking about it, but we're focusing on really the production readiness. It's a lot of work. If you didn't know, all of our efforts for Arnold and USD are all open source. So they're on this GitHub. It's open source, so you can see all of the code, everything we do. But not only do you see the code, but you also see how our development process. So you will see the sprints, you will see the tickets, you will see the priorities that are put on the tickets. And you have also the opportunity to create your own ticket, to react, or to submit any pull request. But we're doing all the development in the open for USD. Briefly, what does Arnold USD do? So it's a set of USD extensions and the goal is to be able to represent everything Arnold can render or can process in USD. And we do this through extensions, through extensions to USD itself or to Hydra, which is the interactive rendering framework that works with USD. Right? So the kind of things that you want to represent in USD that is not part of the standard are typically shaders. Like all the Arnold shaders they have a representation in USD through our extensions. All the shapes also. Some of the shapes are not part of the USD standards, such as an implicit surface or our volume representation. Some of our lights, and also very Arnold-specific features such as operators. Then we can express them in USD, and so you can use the power of USD and all the tools to create your pipeline in USD, but manipulating Arnold entities. So you can consume USD in various ways in Arnold. The first thing is that the USD file format is an equivalent to the AS file format. So it's a scene file format for us. You can use USD as an archive, a render archive file format. So that allows you to, first of all, you can export from any of the plugins we have. You can export to USD directly, and it contains all the scene, the entire scene, the shading, the images, everything. Everything is in there. And there's really a one-to-one mapping with what we have in an AS file. The advantage of USD over an AS file is that it can contain several frames, like an Alembic file. Okay, so you can kick directly a USD file. So that's the first way to ingest and to work with USD. The second way, and that's an even easier way, is to use USD as a file format input for procedurals. So which are known in Maya as stand-ins. So as you would have an Alembic file or an AS file here, you can use a USD file. And that gives you the same workflow and the same capabilities that you have with other procedurals. So you'll load this at render time, you will have a viewport representation, you can dig, you can explore the internals of your USD file, as you can see here, and you can apply overrides, you can apply operators, you can assign shaders, you can do whatever you want that you were able to do on an Alembic file, for example. So that's a very lightweight way to ingest a USD asset. And of course, we have what is called a render delegate. So that's a Hydra render delegate. So this is the the hard drive framework that I was talking about. This is an interactive rendering framework, and we have the Arnold component for this. This allows to support interactive edits and interactive rendering in all the applications that support the hard drive framework. Such an application is Maya with the Maya USD plugin. So with Maya USD, which is something we support also, you can render in the hard drive viewport, and you'll see the result in Arnold. You can do many other things in Maya USD and Arnold. Well, as is shown here, we support the Bifrost extension to USD as well. So you have the power of Bifrost and USD within Maya, if you want. But we also support a shared space, so the shared stage, USD stage between the Maya proxy shape in Maya USD and the Arnold procedural. So what this means is that what you see in Maya, you can edit the stage, and it updates interactively what you see in the Arnold render view. We also support Houdini Solaris, and I would say it's like a lot of our users are using Solaris. We've been supporting it for a long time. It's a long road. There's lots of things to support. Also, you should know that both USD and Houdini Solaris are moving targets, so that makes it difficult for us. But everybody is collaborating and everybody's working together to make this go forward and benefit, and so that it benefits the whole industry. And I would like to play a little video that my colleague Pal, who's working on USD specifically, has put together, where he's demonstrating the workflow, like some of the workflows you can do inside of a Houdini Solaris with Arnold. I play that now.
Hey, my name is Pal Maze, and I'm one of the developers working on our USD integration and tools. Today I'm going to talk about two of the new Solaris features we included in our latest release, Arnold 7 and Houdini to Arnold 6, deep rendering and render time procedurals. But first I'm going to put together a small test scene to work with. Let's start with render time procedurals. The new release ships with a collection of Arnold USD schemas, small building blocks to describe Arnold-specific primitives in a USD context. These blocks allow you to have Arnold primitives in your stage, otherwise not present in USD. Think of Arnold procedurals, shapes, and lights. For now, we focused on supporting the render time procedurals, ASS, USD, and Alembic in Solaris. Why is this important? At the moment, USD and Hydra are still a quickly moving target. Lots of Arnold native concepts are hard to express, and we are limited to workarounds that can break easily. For example, mesh lights don't work well in Solaris. Mesh lights are missing from the light loop, and Hydra cannot track the relationship and the updates between the light and the mesh. By using render time procedurals, it's possible to work around these limitations and import Arnold scenes directly. I prepared a simple ASS file that contains a mesh light using a torch, so let's import it in our scene. First, I'm using the primitive block to put my Arnold procedural schema into scene. Then using the Edit Properties block, I can change the primitive's parameters. Houdini lists all the parameters available for our schema, so I can drag and drop them to the Edit Properties block interface. For now, I'm only using the file name parameter to point the procedural to my ASS file. Since the Arnold procedural inherits from standard USD-GM schemas, I can use the transform loop to apply transformations. And there you go, the mesh light is visible in the scene. Once I merge the procedural with the rest of the scene, we can see that everything renders together as expected. I can do the same using an Alembic file. The Arnold Alembic USD schema renders Alembic files directly. I can also set the frame parameter to import animation with correct motion blur. One of the advantages of choosing Arnold Alembic over referencing Alembic files in USD is that the Alembic data is only read during renders. Your USD stage won't be cluttered with thousands of primitives, so everything renders quicker. The disadvantage is not possible to edit individual primitives from the Alembic file. Native Houdini lobs work as expected. I can create a new material using the material library lob and assign it to the Alembic procedural. Let's stop here for a second. As you can see, the schemas are elementary building blocks, as I mentioned earlier. It's important to mention that the initial release of this new feature focused on empowering pipeline developers, and flexibility was our primary goal. We are actively looking at providing tools that will allow you to import Arnold native file formats with ease or use Arnold characters. The next feature is deep rendering in Solaris. It is straightforward to set it up. First, let's create an endeavor, just like with standard EXL files. I'm just going to set it to the RGB AOV. Then create a render product, connect the endeavor, and set the output file. The next step is the most important. Change the product type from master to deep. Solaris now knows that this is a deep render product, and it will let Arnold take care of outputting the EXL file instead of relying on Husk. The rest is straightforward. Create the render settings, the USD render lob, and start your render. Let's look at the contents of the rendered DPXL file. To do this, I will import the lob camera and use the deep to points tool from the external QLib library to display some nice and colorful points.
All right, so that was Pav's presentation. As you can see, it's very technical, very, very deep. There's lots of detail, but I hope you can get a glimpse of like how serious we are about making Arnold first-class citizen in Houdini Solaris with our work on the Arnold render delegate and USD. And also, I'm very pleased to share this tweet with you from Megalis VFX. So they shared the first production images from this upcoming Netflix TV series. It's called Oni, and as you can see, we love the look is great. It's got this stop motion realistic look. It's looking amazing, and they very kindly tweeted that they are using Arnold and Solaris with USD for this show. So let's jump to the conclusion. I'd like to discuss a few miscellaneous features that we introduced recently before we go to Q&A. So, well, first of all, I'd like to say that because it's a big number for this release, like Arnold 7.0, and what we do as developers whenever we have a big version jump like this is, but it's the opportunity to introduce really big changes in the API and in the architecture of the renderer, and that's what we did. So it's not as user-facing as some of the features, but it's important for us, and I think we'll reap the benefits of this later. But it was an important groundwork that we did for 7. So I want to highlight a few things. So one of such big changes is the ability to have multiple shader outputs. So previously in Arnold, you could have a single output type. So any shader would output, say, a single color or a single float or an int or whatever you wanted, but just one output. Now you can have several. So you can have several colors. You can have 3 colors and 1 float, whatever you want. There's no limitation. So this is useful. This is more convenient also for some type of shaders that output many things at the same time. I think it's going to be more convenient for artists also. It's going to reduce the number of nodes that you put in shading networks. For now, it's exposed just in OSL because you can write such a shader in OSL yourself. So if you code an OSL shader that has several outputs, that's going to work directly in Arnold 7. and we'll take advantage of this feature for our own shaders later. But it's there. So quickly some of the features. So lots of requests for new images. So we introduced the ability to apply alert to do tone mapping in images, also color curves. You can do this as an imager. Those were the most requested images. More coming. We've introduced Sss Sets with the random walk SSS. I'll explain. This is the image that is on the right. That I'll explain better in the next slide. Very important for studios is now that you can render with multi-party XRs. So multi-party XRs is a way to save EXRs that makes it fast to load just a single layer in an XR file. Like if you have an XR file that has lots of AOVs inside, lots of layers, if it's non-multi-part, it's going to take a lot of time to load because it's loading all the layers. And then even if you're just using one layer, it's going to load everything. With a multi-party XR, it's just going to go directly to the layer you're interested in. So it's much faster to load if your XR contains a lot of layers. And we've upgraded Material X and Cryptomatte to the latest versions. So let's talk about Sss Sets with random walk. So the random walk mode for subsurface scattering is the mode that everybody loves. It's the most realistic look. It's great for skin. It's great for character. It's just great generally for SSS. But it had one drawback. It didn't support Sss Sets. And now you can use Sss Sets. So if you don't know what Sss Sets are, it answers this problem. You can have, if you look at this model here of teeth and gum, both the teeth and the gum have SSS. They have different materials, but they both have some subsurface. But the problem is that even though they are close to one another, there's no light that goes through, that goes from the teeth to the gum or from the gum to the teeth. And thus, you have this darkening. You have this dark line between the gum and the teeth. And that's not realistic. There should be some light coming through both of those objects. Same here at the intersection. So it's subtle, but there's a darkening. Now, if you tag both objects to be in the same Sss set, then the light is going to go through. And so the darkening is gone. You can see it very clearly on the bottom row of the teeth here. Okay, I'm going to go back and forth so that you can see the difference. I know it's quite subtle, but yeah, this is before. You see it's dark, and this is after. It's more realistic. Before and after. Okay. Another big change that we've done in the architecture of Arnold is that we have now multiple render sessions. What does it mean? It means that you can render several scenes at the same time within the same process. And this is important for cases where you have a main scene that is rendering and you have a sub-scene such as a shader ball, a shader preview that is rendering at the same time. Previously, it was a big limitation of Arnold. You could just have a single render happening in the same process. And so if you had the case I mentioned earlier, well, you had to stop one to do the other, and that was not convenient. This is a demo of now this new ability, where you have 9 different renders with different overrides, different settings, all rendering interactively in the same process. Okay, we're going to leverage this more and more in the plugins. And lastly, I'd like to show this very cool feature, which is a bit nerdy. but you can render in the terminal now. So this is rendering inside a terminal where you launch Kick, and without any window, it renders directly in the terminal in low resolution. So why did we do this? Because it's a bit crazy. Well, we did it because it's fun, but it's also useful. It's useful when you remote log into a render node or a remote machine, and you want to just make sure that it renders. Like you want to have a preview of your scene, and you want to make sure that it renders well. And as you can see, it's also fully interactive in the terminal. So it is useful sometimes. Okay, so that was the last fun feature that I wanted to present. And now let's move to some Q&A. Let's see. Yeah, we have about 10 minutes. Right, so I'm going to stop sharing. And let's see if we have any question or any discussion. So I have a question that I don't quite understand here. The denoising techniques. I won't go into too many detail. Like, first of all, because I don't master all the technical details. I'm not the specialist for this in the team, not at all. But I would say if we go back to the slide that I presented with the there's really two classes of denoisers. There's AI accelerated, deep learning accelerated ones. That's the optics and Intel denoiser, and they're just based on machine learning. So there's no wavelet or whatever. It's just through this, and thus it's very fast, but it's more approximate. It works really well, so you should definitely try it, especially with the Intel Denoiser. It works everywhere, and it's fast enough for interaction. Okay, the Arnold Denoiser is not AI accelerated, not AI based. It's more based on the type of techniques that you are mentioning here. I hope I'm kind of answering your question.
Yes, we have. Are you able to see the discuss tab of it? Yeah. Okay. Yeah. So that's all we have, and I think it's a wonderful session. Frederic, I am not very technical, so I'm sure the audience must have been. They could have related to your session a lot, and this is the last session for the day. So,
okay, so I can answer some things. So yeah, so there's the same question.
Good for rendering is a question.
Yes, it's good for rendering. Arnold is used in most of the shows you are seeing. I can say that you can see some Arnold in The Mandalorian. You can see some Arnold in Stranger Things, Game of Thrones, like all the TV series. Like they have some Arnold. Arnold is not necessarily the only renderer that is used, but it's used in like a lot of shows that you.
Do we have any upcoming famous shows that are coming up which they have used Arnold?
Yes.
Okay. I don't know if you can give the names.
No.
No? Okay. All right. Yeah, I think that's it. We have one more question. I think you've already answered that. Arnold is a better option. So can you give some clarity on image designing techniques like spatial filtering, transform, domain filtering, and wavelet thresholding method?
So that's a question I answered before.
I've answered. Yeah. Okay.
Yeah.
I think that is all. And we have no more questions.
All right. Okay then. All right. I hope you enjoyed the presentation. Yeah. If you want to ask a question, now is the time. But I understand everybody's tired of the of the day,
Yes,
and
it
everybody
started
wants
at
to.
2 p.m. and it's been almost 6 hours. So I'm sure
Okay.
they're waiting to go back home. But thank you so much, Frederic, for taking out time and
Thank you.
for accepting the invitation to be a speaker in VFX Summit 2021. So
Thank you
we
for
look
the.
forward to 2022, and it's going to be a physical event next year. So we will want you to come to India.
I'd love to. I'd love to.
Yep. Yeah. We'll keep
Right.
in touch. And thank you so much, Frederic. You have a great rest of the day.
Thank you.
Yeah.